I have been building a few simple projects using the Atmel Software Framework in order to demonstrate the ASF design process. This project is a basic HID device mouse, which was built in a previous video. In this video I will demonstrate the ease of platform portability supported by the Atmel Software Framework by moving this project from an XMEGA-A3BU Xplained to the SAM4S Xplained. Let's start by recapping what this project does. We first initialize the clocks, the interrupts, the board, start the USB stack, then if there is a high on the USB bus, we attach. The user interface is simply a left mouse button using push button 1. We initialize the vendor ID as O3EB, which is the Atmel vendor ID, and the device product ID as 1234. If we run the project, notice how Windows detects a USB input device. The hardware ID of this HID compliant mouse matches the product ID that we defined in our project. Let's add a user application template for the SAM4S Xplained to our project solution. We now set this project as the ASF startup project. Now if we click on the ASF wizard, ASF modules will be added to this project. Search for USB, adding as before the HID mouse to our project. In the ASF Explorer we can now find the USB HID mouse Quick Start Guide for the SAM. This is the same Quick Start Guide as before, but now we are interested in the SAM4S settings. As before, we start by configuring the clock. The main clock crystal is used as a clock source for the phase lock loop 1. PLL1 multiplier is set to 16 and the divider to 2. Given that on the SAM4S Xplained the main clock crystal is 12 MHz, this gives a PLL frequency of 96 MHz. Given that the USB clock divisor is set to 2, 48 MHz is provided for the USB. So the default clock configuration options on the SAM4S Xplained are actually what is required for our USB application. Our XMEGA application can now take on the role of example project that we can use to copy configuration settings. Conf USB can be copied directly from the XMEGA to the SAM. The only value that we should perhaps change is the device product ID. We set this to 4321 instead. The reason we change this is so that Windows will know to look for a new driver. The contents of main are copied as well. For now, just leaving out the user interface. Let's check the debug configuration for our SAM4S Xplained. We can now program the board. Windows discovers a new USB input device. Which has a hardware ID equivalent to what we just programmed. Now let's look at the user interface function. board file for the SAM4S Xplained is the SAM4S Xplained.h. In this file we will look for equivalents for gpio push button 1. gpio push button 1 exists in this board as well, so we can use this unchanged. However, for a LED we can use LED 0 gpio. In the XMEGA, no special initialization is required before we can start using gpio. The XMEGA has only a single peripheral clock which clocks all the I/O pins. If the core is running, the I/O clocks are running. However, the SAM has a more advanced architecture. Each port on the chip has a separate clock domain. For power saving reasons in ASF, we don't enable them all by default. If we look at the PIO Quick Start Guide for the SAM, we can see that we must enable the peripheral clock before using a gpio. From the board header file, we can see that there are a number of defines associated with each PIO, one of which is a peripheral clock ID. We turn on the peripheral clock for the switch. Then program the board. As before, we now have a HID compliant mouse with a push button configured as the left mouse button. My standard PC mouse is still moving my mouse cursor, but the SAM4S can be used to click or double click. We have now completed moving our HID mouse from the XMEGA-A3BU to the SAM4S Xplained. ASF has made this a reasonably simple task.